This is Mrs. Zappia with Lesson 9 from Module 3, using if-then moves in solving equations. Student outcomes for this lesson. Students understand and use the addition, subtraction, multiplication, division, and substitution properties of equality to solve word problems leading to equations of the form px plus q equals r and p times the quantity x plus q equals r, where p, q, and r are specific rational numbers. The essential question for Lesson 9. How do I use the properties of equality to solve word problems? How do I use a two-way table to help write an equation to solve a word problem? Pause the video and complete the opening exercise for Heather and Jake. Figure out how much time they practiced soccer. So let's go over the answers. Heather practiced soccer and piano. She practices every day for 2 hours. And after 5 days, she practiced both piano and soccer for a total of 20 hours. Assume that she practiced soccer the same amount of time each day. How many hours per day did Heather practice soccer? So Heather's equation is 5 times the quantity h plus 2 equals 20, where 5 represents the 5 days. We add together h plus 2 because h represents the amount of soccer every day and 2 represents the piano every day. So we add those together and then multiply them by 5, and that equals 20 hours of practice. Now, Jake's soccer and piano practice is a little bit different, although it's very similar. Over 5 days, Jake practices piano for a total of 2 hours. So his 2 hours here does not get multiplied by 5. His soccer does, because he practices soccer for the same amount of time each day, over 5 days. And he also practiced a total of 20 hours. So let's go ahead and simplify these equations and solve them. And remember to simplify first using PEMDAS. So there are no parentheses that we can do anything with, no exponents. Right here we have multiplication, so we'll multiply 5 times the quantity, and that's our distributive property. So we have 5h plus 10 equals 20. There's nothing else to simplify. So now we're ready to finish with PEMDAS O, and that's going to go the opposite direction to solve the problem. So we're going to undo addition and subtraction. Here we have adding 10, so we are going to do the opposite, which is to subtract 10. So what we're doing here is we're taking away the hours of piano, and we'll be left with the hours of soccer. This gives us a 0 pair, and 5h plus 0 is 5h. That's the additive identity. And then 20 hours of practice, take away 10 hours for piano, leaves us with 10 hours for soccer. We take that 10 hours and we split it evenly among the 5 days. This is the division property of equality that says that if you divide by the same number on both sides of the equation remains equal. So a number divided by itself is 1. 1 times h is h. And 10 divided by 5 is 2. So h equals 2, and that means that Heather practiced soccer 2 hours per day. Now solving Jake's equation. He practiced 2 hours over the whole week. So let's take away his piano hours. And this equals a 0 pair. 5h plus 0 is 5h. And he is left with 18 hours of soccer. Then we split that 18 hours evenly between the 5 days because it says he practiced the same amount of time each day. So we divide by 5. A number divided by itself is 1. 1 times h is h. 18 divided by 5 is 3 and 3/5. So Jake practiced 3 3/5 hours every day. We can write that answer in a couple of different forms. We could also convert it to a decimal, and that would be 3/5 is equivalent to 6/10. So we could say that it's 3.6 hours as well. Or if we wanted to convert it to minutes, 3/5 of 60 minutes. We can simplify the 5 and the 60, divide by 5. And 3 times 12 is 36, and 36 over 1 is 36. So we could also answer this as 3 hours and 36 minutes. So here we have two different units of measure. Here we have 3.6 hours, or 3 3/5 hours. In example 1, Fred and Sam are a team in the local 138.2 mile bike and run-a-thon. So here we have their total distance. Fred will compete in the bike race. So this is Fred, he's doing the biking, and Sam will compete in the run. Fred bikes an average speed of 8 miles per hour. So Fred is 8 miles per hour, and that is his speed. Sam runs an average speed of 4 miles per hour. 4 miles per hour is his speed. The bike race begins at 6 a.m., followed by the run. Sam predicts he will finish at 2:33 a.m. So they begin at 6 a.m., and he predicts that they will finish at 2:33 a.m. So we know the total distance that both of them will go, but we don't know how far Fred is biking or how far Sam is running. We also don't know how long each one of them is going to take. How many hours will it take them to complete the entire bike run-a-thon? Well, if we go along with Sam's prediction, we can figure out about how long. So we know that they're starting at 6 a.m., and we need to figure out how much time passes before 2:33 a.m. So let's figure 6 a.m. to 6 p.m. 6 a.m. to 6 p.m. is 12 hours. And then 6 p.m. till midnight. Midnight is 12 a.m. So another 6 hours. So we have 12 hours plus 6 hours, plus from 12 a.m. to 2:33 a.m., that's another 2 hours and 33 minutes. So how many hours it will take? We have 12 plus 6 plus 2, and that gives us 20 hours and 33 minutes. But the question is asking how many hours, so we need to convert this 33 minutes to hours. So first let's write it as a fraction. We have 20 and 33 out of 60. And to convert that to a decimal, you can either use your calculator, 33 divided by 60, or you can use your fraction to decimal key. And that equals 20 hours and, well, 20.55 hours. So there's our answer. That's 20 hours they're going to be biking and running. Next, if T is how long it takes Fred to complete the bike race in hours, write an expression to find Fred's total distance. So T is going to be Fred's time, how long it takes. That's going to be time. Write an expression to find Fred's distance. Well, there's a formula called the distance formula, and it is distance is equal to rate times time. And you can use that formula to calculate either distance or rate or time. So we're going to use that. We know that Fred's speed is 8 miles per hour. And another name for speed is rate, because you're comparing his miles and his hours. And that's a unit rate. So we have 8 for the rate. And then it says T, how long it takes. Well, we don't know how long it takes. So we're going to multiply 8 miles per hour times the time, and that's going to tell us the distance. So that's using the distance formula. This problem, however, says expression, not equation. So we just want to talk about the distance. Well, the distance is 8 times t. So we're only going to talk about that, 8t. And that represents Fred's distance. Part C. Write an expression in terms of t to express Sam's time. Well, t represents Fred's time. So when we're talking about Sam, we have to do it in relation to Fred's time. It's a little confusing. We know that the total time is 20.55, and we know that t is Fred's time. Well, that 20.55 makes up Fred and Sam's time. So if we start with the total and we take away Fred's time, we'll be left with Sam's time. So the expression for Sam's time is 20.55, take away Fred's time, which was t. Next, write an expression in terms of t that represents Sam's total distance. So again, we'll start with the distance formula. D equals r times t. So rate times time equals distance. And the rate, okay, we're talking about Sam's rate now, and Sam's rate was 4 miles per hour. So for the rate, we'll put 4. And then Sam's total distance. Well, we need the time for Sam, because Sam's distance is equal to Sam's rate times Sam's time. So Sam's time, we wrote an expression right here. This is Sam's time. So we'll substitute that for the t, and that is 20.55 minus t. So the 4 represents Sam's rate, and the 20.55 minus t represents the amount of time that Sam will be running. And that's an expression, so we will not use the d equals. So right here, this represents Sam's distance. Next, write and solve an equation using the total distance both Fred and Sam will travel. Now this one is going to be an equation, so it will have an equal sign. And we know how far the race is altogether. So Fred is going to be doing the biking, and Sam is going to be doing the running, and we know that their total is 138.2 miles. We know that Fred's distance, we calculated it right here, or we wrote an expression for it. Fred's distance is 8t, and that means 8 miles per hour times the time he travels, and that represents his total distance. And then Sam's distance is right here. Sam's distance is 4 times the quantity, 20.55 minus t, where 4 represents Sam's speed and this represents his time. So together that represents Sam's distance. And we know that their total is 138.2 miles. So write the equation. Done. Now let's solve it. When you're solving an equation, remember that you are going to simplify using PEMDAS. And after you've done that, PEMDAS, you're going to solve the equation going in the reverse order through PEMDAS. So first, let's simplify. In the parentheses, there's nothing that you can do because they are unlike terms. There are no exponents, so complete any multiplication and division. Well, this is multiplication right here, 4 times the quantity. So we need to distribute the 4 to the first and the second term. Go ahead and just bring down the 8t. 4 times 20.55 is 82.2 minus, see the minus, 4 times t is 4t, and then bring down the equal sign and the 138.2. Next, we can see if we can simplify anything with adding and subtracting. And I see that we do have like terms, so we can combine our like terms of 8t minus 4t. And 8t minus 4t is 4t plus 82.2, and that's going to equal 138.2. Then we've got our equation. And notice in the student outcomes, it talked about P times the quantity X plus R, or Q plus R. This is what they're talking about, where you have a coefficient and a variable, PQ plus PR. This is what they're talking about. Basically, it's just a two-step equation. So what are the two steps? We're going to go backwards through the order of operations and undo any addition and subtraction. So we're going to undo this addition with the opposite. We're going to subtract 82.2, subtracting 82.2. And notice that I didn't show my operation on the right side. Well, this is the subtraction property of equality that says that if you subtract one number, you have to subtract the same number from the other side of the equation so that your equation remains equal. So this equals a zero pair. Bring down your 4t, and then 138.2 minus 82.2 equals 56. Next, we have 4 times t equals 56, and that means multiplication. Well, you're going in the reverse order. So next is multiplication and division. We're going to undo this multiplication with the opposite operation, which is division. We're going to divide by 4. The purpose of dividing by 4 is to isolate the variable t. A number divided by itself is 1, and 1 times t is t. And 56 divided by 4 is 14. So we have solved the equation. It says write and solve an equation using the total distance both Fred and Sam will travel. So what we came up with was t equals 14. But 14 what? What does that t represent? So let's go back and see what t represents. Write an expression. Here we go. T is how long it takes Fred to complete the bike race in hours. And then here's another t right here. For Sam's time is 20.55 minus t. So t represents Fred's time. So it says, how far will Fred bike? Well, t is Fred's time. So let's go ahead and label that. Fred's time is 14 hours. And it says, how far will Fred bike and how much time will it take for him to complete his leg of the race? So we know that the total is 20.55 hours for the whole race. And Fred's time is 14 hours. How far will he bike? Well, remember the equation for distance? Distance is equal to rate times time. We know that the distance is what we're looking for. And actually we use a small d for distance here. And the rate is 8 miles per hour, and Fred's time is 14 hours. So 8 miles per hour times 14 hours is Fred's total distance. And when you multiply those, you get 112 miles. 112 miles. I hope you can appreciate how far that is to ride your bike. It took him 14 hours, going 8 miles per hour. How far will Sam run, and how much time will it take him to complete his leg of the race? So we know that the total time is 20 hours or 20.55 hours, and we know that Fred's time was 14 hours. So if you subtract, that's going to give you Sam's time. And we saw that on the previous page right here, that Sam's time is 20.55 minus t. So we do the subtraction, and we get 55, 6. So we have 6.55. 6.55 what? 6.55 hours for Sam's run. It also says, how far will Sam run? So we can go back to the distance formula. Distance is equal to rate times time. Sam's rate is 4 miles per hour. Sam's time is 6.55. And we can multiply those to get the distance. Another way to get the distance would be to subtract. We know that 138.5 is the total distance. And I want to double check, it's 138.2. 138.2 is the total distance. And then 112 miles is the amount that Fred biked. And if you subtract those, you get the distance that Sam ran. And when you subtract that, you get 26.2 miles for Sam. So I don't know if you know this or not, but in an Ironman, there's a race where the person swims 2.4 miles, then they bike 112 miles, and then they run 26.2 miles. And that is a total of 140.6. You might see that on the back of some people's car. That's the distance for an Ironman. And then you'll notice that Fred biked that distance, and Sam ran 26.2, which is the distance of a marathon. All right, so we've answered those questions, and it just says fill in this chart to help you determine the sign. The total time in hours, and then Fred's time, and then Sam's time. So if the total hours was 10, and Fred took up 6 of those hours, then the total time would be the difference. So 10 hours minus 6 hours is 4 hours for Sam's time. If the total was 15 hours, and then you could take away Fred's time, and that would leave you with Sam's time. And then if the total time was 20, and you took away Fred's time, that would leave you with Sam's time. And again, the total time, take away Fred's time, is Sam's time. And finally, 20.55, which is the total time, take away Fred's time, is Sam's time, which is 20.55 minus t. And again, we had that labeled on the previous page when we were looking for Sam's time, right here. So setting up this information in a two-way table. Two-way tables can be a handy way to help you set up story problems. So here we have Fred, and we have Sam, and then we have their rate, and their time, and their distance. So on a two-way table, one of the ways is the people, and then the other way is their rate, time, and distance. So we know that Fred's rate was 8 miles per hour, and that Sam's time was 4 miles per hour. It's said to use t for the time for Fred, then Sam's time compared to Fred would be the total of 20.55, take away Fred's time, and that is Sam's time. Then the distance, we use the distance formula, which is distance equals rate times time. So distance is equal to rate times time, so 8 times t. And then Sam's distance is his rate of 4 times the quantity 20.55 minus t. So we set this table up using the 3 key elements of rate, time, and distance. So now let's use this like concept of a two-way table in the next example. Shelby is 7 times as old as Bonnie. If in 5 years the sum of Bonnie and Shelby's age is 98, find Bonnie's present age and use an algebraic approach. So these kinds of problems can be confusing, and a two-way table can help you organize the information. It says that Shelby is 7 times as old as Bonnie. So we have 2 people that we're talking about, Shelby and Bonnie. And you know a little bit about Shelby. You know that Shelby is 7 times older. So Bonnie is the unknown. So Bonnie is the one that we'll use the variable for. So let's use X for the age of Bonnie. And we're talking about two different ages here. We're talking about the current time. It says Shelby is, and then it says if in 5 years. So that's a future age. So we'll use two columns. We'll use one for the present age and one for the future age. And it says Shelby is 7 times as old as Bonnie. Well, if Bonnie is X years old and Shelby is 7 times that old, then we would write that as 7x, which means 7 times x. And it says if in 5 years, well, how old will Bonnie be in 5 years? She'll be her age plus 5 more years. So she'll be x plus 5. How old will Shelby be in 5 years? Well, she'll be her present age plus 5 more years. So 7x plus 5. Next it says, in 5 years, the sum of their ages is 98. So we want to use their future ages and find their sum. So we're going to add these two together. So our equation would be Shelby's age of 7x plus 5 plus Bonnie's age of x plus 5 as a sum of 98 years. So now we want to solve the equation for x. Remember to use PEMDASO. We have no parentheses because even though there are parentheses, you can't add 7x plus 5. So we continue. There are no exponents. There is no multiplication or division. There is addition. Notice that this is all addition. So you can do this in any order and any grouping. So we have 7x plus 5 plus 5. And that all equals 98. We can continue simplifying by grouping our like terms. That gives us 8x plus 10 equals 98. Now you cannot add 8x and not 10 because they are unlike terms. So now we are ready to solve the equation. When you solve the equation, you go in the opposite direction, undoing addition and subtraction first. So we want to undo adding 10 by subtracting 10. Do the same thing with the same number on both sides of the equation. That's the subtraction property of equality. So we're taking away that 10 years. This gives us a 0 pair, and 8x plus 0 is 8x. 98 minus 10 is 88. Next we have 8 times x. So we're going to undo the multiplication and division. Now this is multiplication. The opposite of multiplication is division. So we're going to divide by 8. Show division with a fraction bar. Divide by 8, and you're always going to divide by the coefficient here because you'll get 1, and 1 times the variable is the variable. And then 88 divided by 8 is 11. So we have solved for the variable, but the question was asking, find Bonnie's present age. So x equals 11, and x is Bonnie's age. So that means that Bonnie, write that a little neater, that Bonnie is 11 years old. And you always want to be careful because sometimes they'll ask about one person or the other. If the question said how old is Shelby, then you would have to multiply 7 times 11, and Shelby is 77 years old then. So be careful about which question they're asking. In this lesson, you have learned to create a two-way table to write and organize expressions. Then use the expressions to write an equation to solve a problem.